it's drink. Like it's
Like-
kind of like an energy drink, but not like as much energy as like a monster.
Oh, okay.
Like it's cool.
Well, you're a good friend.
Yeah, and then she's mean to me. And I parked in the cage lot for her.
Now that's
Yeah.
No, the
a
cage
ride or
lot
die.
no, it is more. I will time it.
Grace, you don't park in the junior lot, so how would you know?
I will park there one day and time it.
No,
Just
she's gonna walk slow purposely.
no, like I swear,
You think the cage lot is faster than?
it's way closer.
It is
And
closer.
if you speed out of there, then you beat the buses.
Well, now, because can't you guys come in the back entrance?
Yeah, exactly.
Yeah, so
So
I would think that it's, especially, I
Yeah,
mean.
but the people back there are scared.
no, they are not. Katie just doesn't know how to drive.
I
Or
don't know how to drive. This morning, me and Grace were sitting in my car, and this guy was looking at my windshield. I
It
was
was some
really
freshman
scared.
though, so like, I don't know.
It was really weird.
Katie
Made me
doesn't know how to
uncomfortable.
park.
Okay,
What?
well,
What did you say about me? Yes.
all right, everybody, let's,
I,
if you would flip to the page in your notes packet that says finding domain algebraically, about halfway through.
oh my God, I was already on that page.
Good. All right, here we go. You ready? Now, stick with me today because I know some of you are going to get confused. I'm going to do my best. We have very nice instructions here sort of laid out for us. But this does take some thought here. So let's read through. We already know what the domain is, the X values that the function's allowed to take on. So notice in this next blurb, most functions will have a domain of all real numbers. This means there are no restrictions to what the value of X can be. So we have an example here, y equals 2x minus 4. You can plug in any number you want in the entire real number system and you will get an answer back out. There's no issues. You're not going to get a 0 in the denominator. You're not going to try and take the square root of a negative number, for example. Those are things where we have issues. So plenty of functions have no issues. So ones like this, domain would be all real numbers. Okay? So the question we need to ask ourselves, are there any numbers that would not be allowed to input X? Hi. Oh my gosh, thank you so much. I thought I'd have to make a special trip down to go get this. Thank you. Well, I'm the treasurer for the teachers union. So like if I have to buy stuff for the, so it's not like my personal packages. That'd be weird, but it's like union packages. All right, anywho. Where are we? Are there any numbers that would not be allowed? We already said no, no restrictions, blah, 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 blah. Okay, so when are there restrictions and how do I find them? Hi,
Deb was here,
yes,
but she's not.
she gave me a paper.
Okay, so she already went down, she left your place.
Yes,
All right, that's what I'm looking for.
okay. There are two things to look for when we are figuring out, hey, are we going to have an issue or not? So the first thing we need to look for, we're going to ask ourselves, does my function have a fraction with a variable in the denominator? We have already talked about these being a problem. Why? Because the denominator can't equal 0. So let's see how you're going to find the domain. All you'd have to do is set the entire denominator only. I don't really even care about the numerator. I just care that the denominator never equals 0. So I'm going to take that denominator, I'm going to set it equal to 0. I'm going to solve for X. Whatever you get, that's what X cannot be. I can have anything else, but I can't have whatever is going to give me a 0 in the denominator. So let's look down at the example. So here I have one of those functions that has a fraction with a variable in the denominator. So this is one of the times I have to perk up and say, oh, this is the time that I need to be careful. So what do? I take just the denominator, x plus 5, set it equal to 0, solve. X cannot equal -5, but I can have anything else. Okay, so there is the domain written in normal inequality notation. How would you write that in integral notation? If I could have anything else in the whole wide world except -5, Go ahead and write what you think that would look like using interval notation. You can have anything else, just not -5. Okay. Jake, how would it look?
It would be negative infinity, comma, -5 enclosed by parentheses. And then a union. And -5, comma, infinity, enclosed parentheses.
Perfect. That's how I would write it in interval notation. Okay, I can have anything else in the whole wide world except -5. So I can go from negative infinity all the way up to -5. But I can't have it, so I'm gonna jump over and then -5, anything bigger than that I can have. So there is issue number 1. Anytime you have a function that is a fraction where there's a variable in the denominator. I don't care if it's just a fraction, if it's just a number down there, I don't care. I care if there's a variable, because variables, I don't know what they are, and I can't ever let the denominator turn into a 0. So far, so good? Okay, scenario number 2 that we gotta watch out for. Does my function have an even indexed radical with a variable under the radical? Can someone explain in plain English what a even indexed radical is? What are those? What does that mean? Even indexed radical. Were you raising your hand?
No.
Oh, I thought you were.
Take a guess.
Well, we know what even means, right? So even, 2, 4, 6, 8, etc. We know what radicals are, right? Do we? Jake, what do you think?
So would it, so that would be that's being raised to an even
What's being raised to the even?
power? Index is not the number that is outside the radical, that the radicand is being raised to.
Not raised to, that's the root that you're taking. So if I'm taking a square root, that's an even index radical, because 2, a square is 2, right? 2, that's even. If you take a cube root, that's not even. So I actually don't care about that anymore. If I take a 4th root, now I care. So let's talk about why I care. Can you take the square root of -8? Not without dealing with imaginary numbers, right? So we're only looking at the real number system. I can't take the square root of a negative number. Can I take the cube root of a negative number? Yeah, -8's cube root is -2. It's no problem, because -2 times -2 times -2 is -8. Can you take the 4th root of a negative number? No, so you see this, that you have an issue every time. It's an even root that you're taking. So a square root, a 4th root, a 6th root, whatever. So most commonly, we're going to see square roots being an issue. Maybe you'd see a 4th root, but any of them that are even. If it's even, I can't have a negative under the radical, because I can't take an even root of a negative number. Okay, so that's what that means. So maybe we should put a little side note so we don't forget. That means we're talking about square roots, 4th roots, and then so on, 6, 8, etc. Okay, so that's what that means, even indexed radical. All right, so what do we do about that? What if I do have the square root of something? So I can take the square root of 0 though, can't I? Yeah, you can take the square root of 0, that's no big deal. But I just can't take the square root of a negative number. So here's what we do. We're gonna take whatever is under that radical sign, the radicand, right? What's under the radical, and I want to make that greater than or equal to 0. And then I'm gonna solve for x. Whatever you get, that's what x must be. Because those are the only things that are going to give me values that I can have under my radical. So let's look at the example. We are asked to find the domain of y equals the square root of 3x minus 4. Square root, that's the time that I have to be concerned. So what do? I take whatever is under there, 3x minus 4, and I set it greater than or equal to 0. Solve for x just like you normally would. Add the 4 over, divide by 3. So the domain is going to be x is greater than or equal to 4/3. So think about it for a minute. If you tried to plug in something that was not in this domain, so let's plug in something that's not greater than or equal to, let's just plug in 1, right? 1 would not be in this domain, correct? 1 is not greater than or equal to 4/3, right? Look what happens. Go back to the example. Plug in 1. Look what happens. 3 times 1 is 3. 3 minus 4 is -1. I can't take the square root of a negative. Yeah, so no wonder 1's not in my domain because it's not a value that I'm allowed to plug in. The smallest number that I can plug in is 4/3. Try it. 3 times 4/3 would be 4. 4 minus 4 is 0. I can take the square root of 0. I just can't take the square root of a negative number. So as long as my x values are 4/3 or bigger, it's fine. That's why that's my domain. Now, take a moment, try and write that domain in interval notation. So think on this. You are not starting at negative infinity here. I can't plug in anything I want. I can only plug in things that are greater than or equal to 4/3. That's where I'm starting. I'm starting at 4/3, and then I can go off to anything bigger than that. So that's what that would look like in interval notation. Does that make sense? Okay. All right, let's see what the next page has in store for us. Oh, yeah. So let's do this first. You're going to see we have 8 problems here. Let me zoom out so the internet can see. There's 8 problems on this page. Real quick, as you're scanning through them, are any of these not going to have any issues? If they don't have, so we have 2 things we're looking for. I can't have, if I have a fraction with a variable in the denominator, I have an issue. If I have an even index radical, I have an issue. Nobody else has issues. It's only those 2 things. So do I have any problems on here that there are no issues? And I can plug in whatever I want for x.
Yes.
What? Which one? Third one, this one?
Yeah.
That one?
And the one above that. No.
These 2.
Yeah.
Maybe I should number them. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so Katie, you said number 4 has no issues. I agree with you. My issues don't involve absolute values. I don't care about. I can take absolute value of anything. Nothing's going to break. That's fine. So the domain for this is just all reals. So I'm going from negative infinity to positive infinity. No big deal. No problems there. Do you see any others after a quick scan that you're like, yeah, that wouldn't have any issues at all? DJ, what was the one you were saying? 6. I agree with you. That's a cube root. So I actually don't care what's going on inside of there, because I also, sometimes you have both issues, right? Like number 7, I kind of have, and 5, I have both issues happening. And then, so we'll talk about those kind of separately, but it is possible to have both issues. But 6 doesn't have either one. I'm not taking an even index radical, and I don't have a fraction with a variable in the denominator. So yeah, 6, the domain would be all reals as well. All right. So cool. We got 2 done really quickly. The other ones might take a little bit more effort. So let's go back to number 1. This one did have an issue. And if you remember from the previous page, the issue is, oh, I have a fraction that has a variable in the denominator. So what did it say we were supposed to do? Braylon? You got it. So look, I literally don't care about the numerator. See you later, alligator. I'm going to take that x squared minus 4, and I'm going to set that equal to 0. And now I need to solve that equation. Okay, what do you get when you solve that? I'd add the 4 to the other side. Yes, positive -2. So let's remember, so now according to the notes, right, once you figure out what x would make you have a 0 in the denominator, which is what this is, right? If you plug in 2 or -2, doesn't it turn the denominator into a 0? Right? Do you see that? So what this means is that my domain gets to be anything else except that. I can't have x equaling positive or -2, but I can have anything else in the whole wide world. So that means my domain x cannot equal positive or -2. So let's try and write that in interval notation. If I can have anything else in the world, just not that. Go ahead and write what you think that looks like. This one's got a couple pieces, huh? All right, let's see. I can have anything else. So I'm going to start at -infinity, and I can go all the way up to, I can go to -2, and then I have an issue. Once I get past -2, I can go all the way up to +2. But then once I hit +2, I got to jump over that also. So that is what I would have written for interval notation. Does that make sense? We're okay-ish? All right, now number 2 is the other type of problem. The other type of problem is, oh, go ahead.
2 in the last one.
One less to do. What lucky ducks. So we can cross off number 8 because we already know once we get through 2, we'll have the answer there. All right, so number 2. This is the other type of issue. This one doesn't have a fraction with a variable in the denominator, so I don't have to worry about that. But I do have an even index radical. So what's the problem though? Why is this an issue? I can't take the square root of a negative. So how do I make sure that I don't do that?
4 minus 2x.
Yes. So that's our fix for this. I am just going to say, all right, I know I can't take the square root of a negative number. So in order to avoid that, whatever is under the radical has to be greater than or equal to 0. So that ensures that I won't be taking the square root of a negative number. Let's just solve this and see what that gets us. Please don't forget that when you divide both sides of an inequality by a negative, what has to happen? You got to flip that inequality symbol over, right? So that's now a positive 2. This is telling you what you are allowed to plug in. So I can put in any value as long as x is less than or equal to 2. I encourage you to test it, right? So, okay, if I plug in 0, for example, that should be fine because 0 is less than or equal to 2. So let's do it. 2 times 0 is 0, 4 minus 0 is 4. I can take the square root of 4 all day long. So yeah, this is making sense. These are the values that I'm allowed to have. So that is my domain. Try writing that in interval notation. If you can have any value less than or equal to 2, how do you write that? Whenever you divide both sides by a negative or multiply, you got to flip that symbol over. All right. Okay, we have this in interval notation, maybe. All right, so anything less than or equal to 2. So I can start at negative infinity, can't I? I can have all those little negative ones. So I'll have negative infinity and I can get all the way up until 2. What do I do here? Yes, the closed bracket, because I am including 2. I can plug 2 in itself, but that's it. So there it is in interval notation. Okay, you try number 3. Oh, that one's actually super easy, but go ahead, try it. Oh, maybe not. There's 2 pieces. All right, you try. See what you can come up with there, and then we'll talk. This one has both of our issues. You see that? It's got both of them. Yes.
I got it.
Oh, you do? Hold on to it for 1 second. Let me let everybody get an answer for themselves.
Can't square an item number. No, you can't.
Don't laugh like that.
You can square a negative number.
I mean,
You can't square root a negative number.
No.
All right. Katie claims she has an answer. What is it?
X has to be greater than 0.
X has to be greater than 0. I agree. So when I have both problems, right? I have both situations here. What I'm going to do is I'm going to figure out what's going on with each of them. And then my final answer has to work for both. Has to work for both. So if I just look at the radical issue, right? That would tell me, okay, so ignore the X on the bottom for 1 second. If I'm just looking at the square root of X, so I know according to the rules, I have to take whatever is under the radical and set it greater than or equal to 0, right? So X has to be greater than or equal to 0. However, I also needed to work for the denominator issue. Oh, sorry, I didn't realize that was off. So the denominator issue, I can't have the denominator ever be equal to 0, right? So X cannot equal 0. So if we put these two things together, if X has to be greater than or equal to 0, but X can't be 0, wouldn't that mean that X just has to be greater than 0 and it will work for both? Do you see that? If I put these two rules together and I come up with a rule that works for both of them, I'll just say, okay, fine. If X is just greater than 0, it works for everybody. So X must be greater than 0 is the domain. Again, I encourage you to check this. If you try to plug in 0, you'll see very quickly, oh, I have a problem. I can't have a 0 in the denominator. It's already broken. So 0 better not be part of my domain. If I plug in +1, you'll see very quickly, oh yeah, that's fine. I can totally do that. If you try and plug in a negative number very quickly, you will realize, oops, can't do that. So this makes sense that that's my domain. Is that all right? You with me? Okay, so we kind of had the same thing going on in 5. I have 2 issues. Let me give you a moment. Try and figure this one out too. You got to figure out how can I fix each individual problem that I have? And then ask yourself, okay, well, can I come up with one domain that works for everybody? That's what I need. Anybody think they have an answer? Braylon, go ahead. X has to be greater than -1/2. Anybody else get that? Yeah, okay. Let's see. I don't have the answer, so I don't know if that's right, but a bunch of you got it, so I'm assuming you are correct. So let's do it together. You heard that, right? Yeah. It hasn't happened in a while, but all right, anyway. So 2 issues. First, I can't ever have this thing down here because it's in the denominator. It can't ever equal 0. Okay, so I'm going to set it equal to 0. And I'm going to solve for it. Okay, because whatever answer I get there, I know I'm not allowed to have. So I can square both sides. 3 plus 6x, 0 squares is 0, minus the 3, divide by the 6. So I know that x is never allowed to be a -1/2. That would make the denominator turn into a 0, and that's a big problem. Okay, let's look at my second issue. Whatever is under the radical is never allowed to go negative. So I need that to be greater than or equal to 0. So let's see. 6x greater than or equal to -3, divided by 6, divided by 6. X has to be greater than or equal to -1/2. So I need both of these to be true. Well, if x is not allowed to equal -1/2, and it has to be greater than or equal to -1/2, let's just get rid of the or equal to part, right? So if x is greater than -1/2, that should work for everybody. I agree with Braylon's answer. So the domain is x has to be greater than -1/2, just not the or equal to part. Does that make sense? Are we feeling okay-ish? All right, now seven's a wild turkey here. This one's got a lot going on here. So, what do you know right away I'm not allowed to have?
-1.
+1. Yeah, +1.
Why is it
I'm throwing it out the window, right? +1 would get me a 0 in the denominator. Can't have it. So I know for a fact I can't have -1. Okay, cool. So X cannot equal a +1, sorry. So the other piece of this is that this whole thing has to be greater than or equal to 0. Do you guys remember how to solve a rational inequality? Go ahead.
Would you multiply it by?
No. So that's always your first instinct, right? You're like, let's get rid of the fraction. So if you do that though, the problem is I don't know what X is. And if if I multiply both sides by a negative, I got to flip the sign over, right? I don't know if it's positive or negative. I have no idea. And if I do that, then I don't even have an X anymore. I just end up with something that says 3 is greater than 0, and I have nowhere to go. So we have other options though. Jake?
Multiply both sides by 1/3.
So you could,
3, isolate it.
where would you go from there? I mean, we can try it. So you'd have 1 over X minus 1 is greater than 0. But now what do you do? Do you remember? It's weird. It's tricky. Okay, so here's what we're gonna do. We're gonna think about this sort of like a case-by-case basis. I want this expression right here to be positive. That's all I care about. I just want it to be positive. My numerator is positive. So if the denominator is also positive, everything's going to be fine, right? Because then I'd have a positive over a positive, and I know it would be greater than 0. So what might be helpful is to sort of draw ourselves a number line and see what we're allowed to have and what we're not allowed to have. We know for a fact that we cannot have +1. So I'm going to put an open circle at 1. I know I can't have it, but let's see what happens if I put in a number over here on this side, like +2, for example. If you plug in a 2, is this expression going to be positive or negative? If you plug in a 2 right there, I don't care what the expression is. Is it just positive or negative? It's positive, isn't it? Because I'd have a positive number on the denominator and positive number in the numerator. So I'm going to get a positive over here. If you plug in a number on this side, let's say 0, don't you get a negative? Right? Do you see that? Wouldn't this turn into a negative now? So these would be negatives. So if I want everything to be greater than 0, that means my domain is kind of represented right here. I can't have 1, but I can have everything past it because that's where things are positive, and that's what I need.
It's greater than
Yes, X would have to be greater than 1 in this case. So sometimes it can get real sort of dicey. Okay, so those ones are the hardest ones in my opinion, because you got to really think about them. Okay, so if you're going to write that in interval notation, would it be the domain? X is going to be greater than 1, so I'm going to not include 1 itself, but I can have everything after it. Okay, how are we feeling?
great.
Oh, good. So one last little tidbit, it says here, sometimes a function appears to have the domain of all reals, but doesn't because of the application it's modeling. So if you look at the next page, we just give you this example. Remember, context matters a lot. So if you just look at a equals pi r squared, yeah, you would think that the radius could be that you go plug in anything, because I'm not taking a square root and I don't have a variable in a denominator. But think about it. If I'm talking about an actual circle, could I have a negative radius? No, so the context would matter here. Okay, so just a side point, if you're doing some problem that's modeling an application, you have to think about those things. Circles can't have negative radii, so even though this function, R could be anything mathematically, realistically, it can't. Does that make sense? Okay, cool. So, any questions right now for this? Yes. Oh,
Yeah,
golly,
it's not that.
yes.
But she sent me a question.
Okay, let me give you some to practice here. What do I got? What do I got? Let's do this one. I have two to choose from, but I think you'll like this one better. One, two, three, 4. Oh my God. 1, 2, 3. For you.
Are all of these circles?
Yes. This is homework. You've got a good 15 minutes to get as far as you can. Did you tell your sister I said hi?
I did.
Ah, does she remember
She
me?
does remember you.
Oh, good. Okay, let me open this up on Jupyter for you, and then I will circulate and answer some questions.
I didn't do number 1.
Yeah, me too.
Well, does number 1 have any issues?
No.
Then it's all reals.
Wait, I don't know. I don't know though. I
What?
don't know if it doesn't have issues.
So there's 2 issues.
The fraction.
Fraction with a square root or a fourth root or a sixth root. I don't think any of these have fourth root or sixth roots, but
No, it's just a square, it's not square.
let me stop the video.